In this video, we ask you to think about the height of a candle burning at a constant rate with respect to the amount of time it has been burning. To prepare you to mathematically investigate that situation, we want to remind you of the work we did earlier in Part B of Question 4 in Investigation 3. That problem told us that the values of y change at a constant rate with respect to the values of x, so we can determine the constant rate of change of y with respect to x, or m, by dividing the change in y by the change in x for any two xy pairs in the relationship, because the rate of change remains constant in that relationship. For the 2 points given to us in Part B, we must designate a starting and ending point so that we can determine the change. Let's start with the upper left point and move to the second point. As we move in this way, the change in y is the value of y for the second point, or 2.2, minus the value of y for the starting point, or 8.2. This gives us a change in y of -6. Similarly, the change in x is 3 minus a -2.2, or 5.2. So, as we move from the first point to the second point, the x value has increased by 5.2 units, and the y value has decreased by 6 units. We can designate these values of change in x and change in y on the graph using line segments like this. We can also see that the constant rate of change of y with respect to x, or m, is -6 divided by 5.2, which is approximately equal to -1.154. This information allows us to express the change in y in terms of the change in x in the following way. Delta y equals -1.154 times delta x. In our work with this problem, we also saw how the change in y and the change in x is different from the variables y and x. If we want to write a formula to express the variable y in terms of the variable x, we must take into account the fact that the value of y is not 0 when the value of x is 0 in this problem. This is an important difference, because when the change in x is 0, the change in y actually is 0 as well. But not so with the variables themselves in this problem. So, what is the value of y when x is 0? We solved for this. We said that if we start at the upper left point and move until the x value is 0, we will change the x variable's value by a positive 2.2. Using this information for the change in x and our formula in Part Bii, we see that the change in the y variable must be -6 over 5.2 times 2.2. This is approximately -2.538. This means that the y value will decrease from 8.2 by 2.538 as we move from our starting point to the y-axis. Therefore, the y value when the value of x is 0 is 8.2 minus 2.538, or 5.662. This is the y-intercept of the graph of this formula. So, because we already know the constant rate of change, or the slope, the formula to express y in terms of x is y equals -6 over 5.2 times x plus 5.662. Question 5 in Module 2, Investigation 4 asks you to draw deeply on your understanding of the concepts we just reviewed to make sense of them in the context of real quantities like the number of hours a candle has been burning and the height of the candle measured in inches. Think carefully about each part of question 5 and provide answers for all parts. Be sure to represent the increases and decreases in the quantities by drawing line segments on the graph. Also, explain how you determined your answers for the questions that ask you to explain. Submit your answers to all parts of question 5 in Module 2 Investigation 4 using your instructor's preferred method by the time and date that your instructor has identified.